Hello, everybody, and welcome to episode 38 of the Bao Podcast. Today, we welcome two people, Kostas Anastasiades and Ben Moins. Both are senior researchers at the Faculty of Applied Engineering at the University of Antwerp. They are also linked to the service platform B.Cycle, where Kostas serves as an expert on circularity, and Ben is the program manager focusing on sustainability. Both authors are writing and conducting extensive research on circularity, recycling, waste management, sustainability assessment, and other related topics. At Bao Living, all these issues are of course close to our hearts, and we also try to do our part to find solutions to these problems. So I'm very curious to hear more about both their research and on the latest evolutions of technology and construction. So let's dive directly into it. Welcome, Kostas. Welcome, Ben. How's it going today?
Great to be here.
Wonderful. So I thought maybe a good place to start would be that you both explain a little bit more about what the elements are that you have been researching the last 6 years. Maybe Ben, if you wanna take the lead.
Yeah. So first of all, thank you for having us. Happy to be here. Actually, for the past 4 to 5 years, I've worked on sustainability assessment in infrastructure projects, more specifically on the recycling of old asphalt in new asphalt. So we call it RAP, the recycled asphalt. And when I'm mentioning sustainability assessment, it's important to note that I've been focusing on two major parts. So on the one hand, the environmental analysis, which is called an LCA, and then also the economic assessment, which is called the LCCA. Maybe the problem that we saw, or at least where the research started from, is actually when you look at asphalt in Flanders, we see that we recycle almost 99%, which is quite good. And actually asphalt is 100% recyclable. So you can ask yourself the question like, okay, why does it need research? Where is the problem? Well, actually everything is linked to the bitumen that we are using in the mix. Typically an asphalt mix consists of like 5% of bitumen.
What's that, bitumen?
Yeah, so bitumen is actually the black product which make the asphalt black, and it's actually petroleum based. So it's a derivative of petroleum extraction. And the main issue is when you look at the 99% that is recycled, only half of that goes back into asphalt. The rest goes to either a non-bound base or a cement-bound base. And of course, in those two products, you don't need bitumen. So actually, you're losing half of the bitumen. And in mass, that only is like 2.5%, so that's not really an issue. But if you look at the price of an asphalt mix and the environmental impact of an asphalt mix, up to 70% comes from the binder, even though it's only a small quantity what you're using. So when you are relocating the problem to, let's say, environmental impacts and economic impacts, the 99% isn't good because we are downcycling a lot. So we had to optimize that one. And so the research was all about what if we use the old asphalt in new asphalt structures, how can we optimize it? Also the link with quality, like what happens in your structure when you're increasing recycling. Do we get the same service life or not? And that's actually where the entire PhD was about. So,
okay, wow, that was already a lot of information. Let's see if I understood that correctly. So a couple of things jumped out. We already recycle 99% of asphalt.
Yep.
Today.
Yep.
Really?
Yep.
So if a road gets like redone, they get everything.
Yep.
And they use it again.
Yeah.
Wow, I had no idea. That's
Everything
very good.
on the asphalt, at least, yes.
Okay. Whoa. And that's been the case for a while already.
Yeah, and actually we are like one of the best, let's say, throughout Europe. The Netherlands also does it very well. But the Netherlands and Belgium, we are definitely ahead of the rest.
And it's like aluminium. You can keep recycling it.
Well, yes and no. So typically what happens with asphalt when you're recycling it or whenever it's on the road, we call it aging. So what it does is like because of oxygen and sunlight, actually your bitumen, it hardens and it needs to be chemically restored. So what we see is that whenever you recycle in small quantities, it's not necessarily an issue. But if you want to recycle it in high quantities, then typically you need a rejuvenator or something like that to chemically restore the binder back to its initial properties. But that can also be done. So we had a test project on that, and everything worked well.
Okay, and so the Bitumen?
Yes, bitumen indeed.
It sounds like a type of Pokemon, but that's
Yeah.
that's how I Bitumen. Okay, so that's the most. So 70% of the CO2 emissions?
Yeah, up to 70% of the CO2 emissions indeed.
Because they say that like asphalt and concrete, is asphalt and concrete, what's the...
So the main difference is that concrete uses cement. It's the
Right.
gray one. Asphalt
Okay.
is the black one, and that uses bitumen as a binder.
For roads mostly.
Yeah, yeah.
And 70% of the CO2 emissions
Yeah.
of asphalt is the bitumen.
Yeah, up to 70%.
Up to 70, yeah,
indeed.
okay. And then you found a way to reuse
Yeah.
the bitumen.
Yeah. So
Okay.
actually we are already reusing it in asphalt. The main issue is that we are typically only recycling it in the lower parts of the road, not necessarily the top part. And in the lower parts you don't need the same quality of material, let's say, as the upper part. But we've done some testing and we can easily also recycle up to 40% in the upper layers without any problem.
Wow. Okay. And that was your research, I mean.
Yeah,
Okay.
indeed.
Wow, congratulations.
Thank you.
And now how does that work? Because it sounds like it's something that's one of those inventions that could make a lot of financial as well as sustainability sense, right?
Yeah. So actually I call RAP, let's say, the black gold of the asphalt industry. So the main part is, when you look at it economically, I mean, binder, depending on the period, because whenever crude oil has a high price, the binder has a high price as well. But we saw that sometimes the price of bitumen can go up to 600 euros per ton, let's say. Whereas RAP, you only need to crush and sieve it, let's say. So that typically has a cost which is at 15 euros per ton.
Oh, wow.
Yeah.
And you want to use the
RAP?
The RAP?
Yeah.
No, you want to the Digimon?
The bitumen. The bitumen.
You want to use that the most because it has a higher quality than the RAP.
Yeah. So actually, what you're just doing when you recycle asphalt is the same like concrete aggregate. So you're just crushing and sieving it, which makes it like a stone, but it still has like the small coating around it with the bitumen, and that's what you want to recycle as much as possible. Not necessarily the aggregate itself, because from an economic point of view and an environmental point of view, aggregates, they are really low cost and low impact, but it's the bitumen which you want to recycle as much as possible.
Okay, wow. And so now you've proven that this works?
Yeah.
And now is it going to get commercialized?
We're doing a lot of work on it. Also talking to, let's say, public authorities. One of the main issues is that when you look at the construction sector, safety is very important and we are quite conservative. So even though research has been showing for a very long time, and I mean already like decades ago, that you can recycle in upper layers, we're still afraid of doing it because of safety. And it's mainly linked to the rolling resistance, so the braking distance. So we are still afraid that if we recycle too much in our upper layers, that the braking distance becomes longer, and that's really a safety issue. So those are things which still need to be looked at, but we are quite confident that it shouldn't be an issue, as long as you are taking it into account from the beginning and you are adjusting, let's say, your mixture design and your structural design.
Okay. Wow. Fascinating. Maybe we switch for a second to Kostas, because that already was very interesting. So I'm also very curious now to hear what you've been working on, because it's all the entire research you both have done is about circularity, right?
Correct.
Okay.
Mine focused on a broader sense of circularity in the construction industry. And to narrow that down, I took pedestrian bridges as a case for my research. To approach circularity then, I first asked the question, what is it actually? What is circularity? And then we have a European framework that is quite interesting. And the European framework says, okay, circularity can be summarized in 4 R's. First one is reduce. So reducing as much material as possible. So reducing your material consumption. The second R is reuse. Reuse components as much as possible as you can before you go to the third R, which is recycling the base material as raw material for creating new components. And then a last one is recover, which is really like a last resort and only applicable to biomaterials. So wood, for example.
Sorry to interrupt, but if you can move a little bit closer to the mic, because otherwise I think it's going to be a little distant.
Going to be difficult?
Yeah.
All right.
Yeah. All right, so you have the 4 R's.
The 4 R's, yes. Yeah. And then the question I asked was, okay, using these 4 R's, how can we design buildings so they are more circular? Or in my case, pedestrian bridges. And then I turned to circularity assessments. How can we assess circularity in a design? And the 2 R's that I had identified that have been tackled the least in circularity assessment and in circular design in general are the first 2, so the most important ones, reduce and reuse. Reduce, I found usually is just approached as, okay, if we reuse as many components as possible, if we recycle as many components as possible, we can reduce the virgin materials that we need in our new constructions. But there's another side to the design story as well. The other side is, how can we optimize our design initially to consume less material, so we also require less reusable components or less recycled material. So I developed a methodology to predict how much material am I going to need to build this pedestrian bridge in my case. So I can compare any pedestrian bridge design to what is required in an efficiently designed structure. So I can assess, is your structure material efficient? Do you actually adhere to the rules of reducing material consumption first? And then I looked into reusing components, because we can reuse as many as we want, but how do we know if a component is going to be reusable over time? Because especially components in outdoor conditions, they deteriorate. How much? Do we know? We have an idea, an indication of how long a component can withstand, but still there is not so much confidence that the material is still apt for reuse. So I developed specifically for wooden structures in outdoor conditions a service life prediction model to assess this reusability over time. So it can also be implemented in the design, because this theoretical service life prediction model also indicates where does the material deteriorate most and why, so we can actually tackle those problems in a design phase already. And so one of the points that I indicated was, okay, at the connections, we always have moisture traps. The moisture cannot get out of the timber component, and so it's interlocked there, and it causes much more deterioration. And we need to reduce that somehow. So you need to optimize the connection system actually in your structure.
Okay. So you focused on the 2 first elements of the entire circularity value chain, if I say it. Okay.
Yeah.
And why on passenger bridges?
On pedestrian bridges?
Pedestrian bridges, yes.
Well, currently our society is going through a huge modal shift. We are changing from using a car for everything that we need to a more sustainable means of transportation. And one, of course, is public transportation, which is known, but of course also pedestrianism and cyclism is prioritized in our current day society. But to promote cycling and walking, you need an infrastructure that is appropriate. And you know, if you are a cyclist, I am a cyclist. in
Yeah,
Antwerp.
same. Yeah, I have no car.
So then you know that it's not always as convenient to travel by bike through the city in a safe way, at least. So new cycling lanes need to be constructed, and it also comes, of course, with larger infrastructural projects like bridges to cross these dangerous crossings, for example, or waterways.
Okay. So if I understand it correctly, if you implement your methodology on a design for a pedestrian bridge, you can identify which elements should be more secure or more rigid, so that they are able to be used longer or with less materials. Or am I understanding it correctly?
It's close enough. I can
Okay.
identify indeed the pain points in the
Okay.
design where you need to focus on. If it's material-wise, do you need to focus on optimizing the connections so you can improve the reusability in the end-of-life phase of a construction? So that means almost like your SAM is constructed. Design for disassembly, for example, needs to be focused on. But also, is your design efficient enough? Does it consume too many materials, or could you do better in your design?
And is it like an algorithm, or is it like a methodology for designing something, or
It's both.
Okay.
It's both. So
Right.
the background is an algorithm, but it's also a methodology to improve your design. Yes.
Okay. Wow. And so, for example, if an architect made a CAD design or a CAM design, both, like the technical drawing,
Yeah.
then you can run the analysis, and you can say you should look here, you should look there. Those are the elements that should be improved for disassembly or for extending the life cycle of the product.
Yeah. Or I could run the algorithm in advance and already give some advice on what the structure should look like to be more efficient, to consume less materials.
Okay. Wow. And today it's being used on I want to say passenger again, but that's not pedestrian bridges. But it could be used on other designs as well in the future.
Yeah, the good thing about the methodology is that it's a methodology.
Right.
And so it can be extended to additional types of structures, but of course the research needs to be extended then as well.
Okay. I always found it fascinating because you guys have now developed something which sounds really promising, but I think from the theoretical framework to making a real impact, it now needs to be translated to, in my mind, but that's because that's my knowledge, to a commercial setting, or like but is that correct? Or like other ways that this gets like implemented in the real world, or how you can start making impact? Maybe if you can say a little bit more about that could also be interesting for the audience.
Yeah, so when you purely look at, let's say, environmental impacts, the LCA, one of the best known examples by companies are EPDs, like environmental product declarations. I don't know if you know them.
No.
Okay, but like EPDs are a set of, let's say, environmental indicators which are predetermined, and then producers of new products, they can do an analysis of their own product, and then it's just a table divided into the different life cycle phases, so going from, let's say, material extraction all the way up to the waste processing of your product, and then it clearly lists all of the environmental impacts. And we are starting to see that those types of documents become more and more important, for example, for public procurement, let's say. That's, there is clearly a shift from purely focusing on the lowest cost price to also, okay, we want some additional information like environmental impacts.
Yes, I can attest to that. It's happening.
Indeed.
Not quickly enough, in my opinion, but it's starting. Yeah. Yes, for sure.
And then when you look at, in my opinion, one of the main advantages of an EPD is that it has to be externally reviewed by a third independent party. So also there is some value to it, saying like, okay, other people first have looked at it, and the analysis was okay, and it's just of a single product. So that's also a disadvantage. So it's quite difficult if you have like a full building, let's say, or an entire building. It is possible to do an LCA of that building based on the EPDs, but that's always product specific.
But an EPD is not what is your algorithm or your methodology. That's not an EPD.
No.
Okay.
So, and maybe that's a good one to explain, like circularity and sustainability, they are complementary, but they are not the same.
Okay. Expand on that.
Okay, so, and you can interrupt me, but when you look at circularity, that mainly analyzes how easily you can reuse your product or recycling, let's say. And it's typically mass-based, right? So you're going to say like, okay, this percentage of my structure can be easily reused or recycled. Whereas if you look at a sustainability assessment, you need those numbers for your assessment, but then you're going to couple a cost to it and also an environmental impact. And actually one of the best examples or paradigms, let's say, is the example of bio-based products. From a circularity point of view, we all know that you want to reuse as much as possible, but when you put it in an LCA, you're saying that if you're burning the product, then you can recover the energy, which means that you do not need to produce the energy in another way. And from an LCA point of view, that's unfortunately better than producing, let's say, new timber. And that's where you actually at the moment already seeing like a paradox between the two.
That's mostly focused on recycling, of course. If you compare
Yeah.
recycling to energy recovery, then indeed you find that the life cycle assessment will show you a better results compared to recycling. Reuse usually still gives better results.
Yeah.
Okay.
So actually, we could elaborate a little bit on that again. If you focus on life cycle assessment as a sustainability analysis tool, the life cycle assessment can be used to compare different materials to each other, and in this way you can choose the most optimal material with the lowest environmental impact. That's one thing, and then you have a material selection for your product. Subsequently, you can just you can use the circularity rules to optimize the design of your products, so it adheres to circularity, so you can optimize reuse, optimize recyclability in the end, and in this way you actually ensure that your sustainability is again improved. Yep. So if you follow these rules afterwards, you will see that in your life cycle assessment you will still get better results than in a conventional product.
Okay. And then what you invented for
what I'm using, I haven't invented it, but I'm using it, yeah.
But what your research was about, where does that fit in that framework?
So if I look at that framework, of course, road is a little bit atypical, because you cannot really reuse parts of it. I mean, it could be interesting when you have, let's say, a road with pavers instead of asphalt or concrete, because the pavers, you can take it out.
What's a paver?
So it's it's a concrete block, let's say, which you would just have on a footpath. I don't know.
Yes.
So and then you can see like, okay, what's the difference between I'm gonna reuse the entire paver versus I'm gonna scoop them up, I'm gonna crush them into an aggregate, and I'm gonna recycle it. So as I said, so I can use Kostas' model to have a score like, okay, you can recycle this mass or you can reuse this mass. But then afterwards, I'm coupling on the one hand the load or the impact of having to process it versus what is my benefit of reusing versus recycling it. Right.
A couple of weeks ago, I was at this event in Ghent about circularity. I don't know if it's called, And Lieve Scherre was there to talk as well. And then Chris from you probably heard from the
the walls.
From the walls. He gave a talk, and he set up a new business. I think it started as an NGO, but it's turning into a business, from what I understood. The Circular Valley Institute. Have you heard about it?
Yeah.
And there, Chris explained that it's like, for example, he made like this spectrum, and he said Gyproc walls in a traditional sense, they are non-circular because the cost of dismantling them and rebuilding them is much higher in manual labor than the value of the materials.
Yeah.
And then he said on the other end of the spectrum, you have like these Lego blocks, he said, from a certain set, like the most prestige and a rare Lego block, which was like, I don't remember, but something like 60 euros for a single block. And he said, that the amount of labor that it costs to remove it and place it somewhere else is so low, especially considering the value of it. So a very easy mathematical calculation. And he said when it crosses a certain threshold, and I forget the threshold, then it becomes really interesting to start reusing materials. Is that the same logic then? Okay. Yeah.
So actually what you're describing what we call it typically is the break-even point. So from the moment that the cost of dismantling and other processing becomes lower than the cost of the product that you can save, then it becomes interesting to recycle or reuse it.
Right. And then I'm maybe getting back, and I'm maybe repeating myself, but I want to understand, like, Kostas, you have that model now. It's an algorithm, it's a methodology. How is that going to make impact? Like, from an academic perspective, you've published it, so now it's free knowledge. It's public knowledge, right? And then it just gets, the knowledge is out there, and it's going to get dispersed by things like this, and then people are going to start using it, or what's the idea to get this knowledge to have an impact? If I make myself clear, I don't know.
You're making yourself clear. Yes, it's actually part of our job today, right? As postdoctoral researchers, the idea of our function is that we write projects, that we cooperate with the industry to bring the knowledge that we already obtained during our PhD out in the world. So we set up cooperations with the industry. For me, for example, very specifically, if I refer back to the service life prediction model that I already worked on for timber structures, I'm developing it further. I'm cooperating with the industry to implement it in an urban mining model for Flanders. So we can assess how much material is available in the built environment, what is the remaining value of that material, and is it recoverable? Can we reclaim it and reuse it? So,
right. Okay. So dispersing the knowledge is now, when the research is published, that's now, as a postdoc, basically the job.
It's part of our job. Yes.
Okay. And so, what if, like an how are they called? The big BIM softwares. I want to say it so many times. I'm a bit slow today. Yeah, Revit. I want to say the other one, Adobe, but that's not true. AutoCAD. So if AutoCAD or Revit comes talking,
AutoCAD is just a drawing software, and Revit is Autodesk's BIM software.
Okay, right. So if they come talking and they say we want to use the methodology in our software, that's also an option.
That's an option, yes, of course. Yeah.
Right. But then you have like those complex systems by which the university takes a part of the... Okay, fascinating. All right. That's way clear already for me. I hope for the audience as well.
I hope as well.
They're free to reach out, of course.
Yeah. So we will definitely put all the information up so if you send the links to your research after the recording, I will send them through to Martin, who does the editing, and then we will all put it in the show notes. So if anyone who's listening to this wants to learn more about these topics or wants to reach out to do collaborations, you can find everything in the show notes. So then during the introduction, we talked about something else, the
B.Cycle. Yes.
B.Cycle, the B.Cycle platform.
Yeah.
Can you maybe explain a little bit more what that is?
Yeah. So actually, B.Cycle is a service platform of our research group, and what we are seeing is that when you go towards, let's say, typical academic research, it are always projects that last 2 to 4 years, and the industry or companies, they don't really have that time often, and they want to have it fast, so they are doing, let's say, consultancy. But on the other hand, because consultancy has to go fast, sometimes you don't have the depth that academic research has. So that's what we wanted to do with B.Cycle, is to combine both and actually help the industry, other stakeholders that wanted to focus on sustainability or circularity. It's just doing like academic research, but at a very fast pace, which actually, makes it more of the consultancy side, but with the depth of the academic research. So that's actually what we are doing with B.Cycle.
So it's a collaboration with private industry?
Yeah. Okay. So indeed, it's the private industry that comes to us with a certain question. For example, the EPDs that we are mentioning, like, okay, can you deliver us an EPD? Then it's a contract directly with them, and then we do the job for them, or just a sustainability assessment or circularity assessment or something like that.
And that's something that you do with the entire department of...
No, so it's like a very specific group. So that's also the difference. Like in a research group, you typically have PhD researchers and so on. Here we just have like regular researchers who can quickly shift focus. And they are not really working on a single project, but they are doing a lot of projects at the same time. So...
Cool. Question: How do you still keep the pace, but also do the in-depth research, while also is there then a higher price than consulting, or because something needs to give, right? I
mean, you know it as well as I do that price is often the most important thing, so we cannot really do it at a much higher price. I think the main reason that we are doing is because we have a lot of researchers working on specific projects, and then I do mean PhD researchers. We have a lot of extensive knowledge on that topic. So for us, it's quite easily to incorporate that knowledge into a project. We're also, we always do literature research and so on. So we also dive into depth in the background, let's say, of a specific problem. And I think that's the main reason why we can go more in depth, but at the same speed of consultancy.
Nice. And that's a new thing that the university offers, or it's been in existence for a while?
I mean, if you look at the service platform itself, is quite new. I think we now exist like a year or something like that. But service platforms have been there for a while. I mean, it's kind of the same as a spin-off. So first, let's say you have the service platform, which still is under the umbrella of the university. But then once, we are self-containing or self-fund, let's say, then it can result into a spin-off.
Cool. Well, that sounds great.
Yeah.
Same as the previous. If anyone would be interested hearing this,
of course, they can always contact me.
Yeah. We will put it in the show notes as well. All right. Thank you already for explaining the specific research that you've done. Maybe if we zoom out a little bit more and we take some more general questions about the industry as a whole, that could be maybe also interesting to look from your perspective as more research, like academic experienced people. We don't get them every day here on the podcast, so it's a different perspective.
We are a special breed.
You could say that, yes.
So maybe fun question to explore a little bit is, are there like historical practices in construction that you think we can learn from today and maybe use more already? Yeah, or we can reuse again and start implementing more and more today. Is that something that you ran into?
Yeah, I think one of the greatest example that you're seeing these days is that we're making the shift back towards bio-based materials, whereas they've been used, throughout centuries. Of course, just like wood construction, but if you look at insulation materials, grass-based insulation materials, they are now finding it in historical buildings, and you're clearly seeing a shift towards those type of materials. So that's a very important one. And then I think the clay-based mortars, leem, is also something which has been used throughout time. So that's also a good example.
Another good one is reusing materials.
Okay.
Until like the beginning of settlements, 10,000 BC till the 19th century in our era, construction materials have been extensively reused because buildings, they don't always stand the test of time. You have an earthquake and a building gets damaged, it got dismantled in earlier times, and the construction components were just reused. They were not recycled or just dumped anywhere like we would do until a couple of decades ago. And then suddenly, in the 19th century, you get the age of concrete that is introduced. This new material that's super interesting, fair enough. But we use it in a way that it makes buildings unreusable. Everything is just fixed, connected to each other. It's very difficult to dismantle. It's very difficult to recycle, also as a material. And suddenly, this reuse is just almost not an option anymore. We also get in the age of mass production which makes materials or components very cheap. What we talked about earlier. And because the materials are too cheap, again, it's not worth reusing them. But we see that materials are slowly coming to an end, right? So we are slowly shifting back. Maybe one more interesting thing from history is one that I found when I was diving into standardization. In Mesopotamia, bricks were used a lot also for construction, just like we use bricks a lot today. Only in Mesopotamia, they had one type of brick. And it was standardized throughout all the different kingdoms of the Mesopotamian.
And when was this? This is like hundreds of years ago, no?
This is like thousands of years ago.
God.
So they had one standardized brick, and a brick had to adhere to these standards. And if it was not this shape and not this quality, it was not a brick, period. And it could not be sold as a brick. It was something unuseful.
Wow, that's a great fact. So thousands of years ago, we already had the common sense to do that in a kingdom spanning countries. And today,
it seems impossible.
Yeah. If you put it in a historic perspective, there's a chance that we look back in like a couple of 100 years and we look at like the last century and we like, oh God.
I think people would laugh at us.
Yeah, yes. Because, I mean, and you can probably explain it, right? That we discovered oil and it gave us so much energy and we went a little bit crazy for like a century. But probably indeed, if you place it already in the historic context that you put there so well, Kostas, it already now, if you look back on it, you're starting to feel like that's kind of strange. But in a couple of centuries, they will probably be like stupid 20th century people.
Yeah, it's true.
Fascinating. Maybe another one that we sometimes run into that you also already mentioned is the conflict between price and sustainability. Yeah. For us, I can only speak from our experience, right? We started with Bao Living, we started with Sam, and for us, the last 6 years, commercializing this product really has been like a journey of price discovery. And it was a necessary trajectory, I think.
Mm-hmm.
But what became really obvious for us, and we heard it throughout all the years, like, but sustainability is becoming more and more important. And it's coming. And even today, it's like, okay, sure. And in the Netherlands, it's already with public procurement, a significant part of the points are your sustainability performance. But for our biggest segment, which is private customers, I mean, it's still, like, I would say 98% price.
Yeah.
And I'm very happy to say that I think since a year or two, we have reached like the same price level as a traditional way of building. And then we see that it can go much quicker. But it's always it's a hurdle, right? And maybe for the biggest technologies who could have the biggest impact, the price can only come after they've seen enough traction to get to volume. So there's always this conflict. Do you notice that as well? Did you run into that during your research? Do you have an opinion about that?
I think, the good thing that I've seen in my research is that whenever I design something which is more environmentally friendly, it's also more cost effective. However, and this is important to consider, I think the main question is whether you're only looking at your initial investment costs versus your total cost of ownership, right? So when you are designing products or processes where circularity comes into mind, let's call SAM, and you need, for example, maintenance. If you have a rigid system where maintenance isn't easily and you have to remove the entire thing, place a new one, then your costs will become higher than if it's modular and you can easily go to your techniques and so on. I think that's an important one. So whenever you look, and we call it the gate, whenever you look beyond the gate and you consider the full life cycle, then I'm quite convinced that the environmental impact and your economic impact goes hand in hand. On the other hand, if the trade-off is too big, then in my opinion, you cannot really say that it's sustainable, because it needs to be a balance between costs, environmental impact, and also social. And that's a pillar which I'm not focusing on, but it's very important to consider that as well. So that's an important, it needs to be in balance. And then I think the most important thing about the sustainability assessment, even if your initial design leads to a higher cost, let's say, then there is a big advantage in a company in doing it, because it also gives you information about your hotspots, both environmental and economic, so you can easily optimize it.
What do you mean hotspots?
So with hotspots, you're just identifying, let's say, the individual materials or processes that have the highest impact in your analysis. In my case, bitumen is clearly a hotspot, because up to 70% of my total impact comes from the bitumen itself. That also, for me as a product designer, let's say, it's easy, or at least it's quite clear that I have to find an alternative for the bitumen. In concrete, people have to find an alternative for the Portland cement. And those are the hotspots that you are identifying. And that makes sustainability also, in my opinion, a dynamic process instead of a static process, because it's always about continuously improving, let's say, the costs of your design and the environmental impacts.
That's very well said. I don't know if you have anything to add, Kostas?
That's basically what it comes to.
Okay.
You follow the circularity rules, on the long term, you're going to save.
From talking from experience trying to commercialize something, that from the very beginning was a total cost of ownership story. I can attest to what you say.
Mm-hmm.
I just noticed in the last 6 years that that's a great story, and they want to go along. let me put it differently. The first couple of years, I was really frustrated at times because I was like, come on, guys. You say you are an environmental developer, but this costs a couple of percentages more than traditional and you're not doing it.
Mm-hmm.
And I was frustrated with them. And then after a couple of years, they became like this realization, but wait, it's also not their problem because they're working in a market which is so price sensitive that the problem, and it's not really a problem, but the reality is all of us.
Yeah.
It's like every single one of us, because if we go and buy our homes, the single most important thing that we also focus on is price.
Yeah.
So for me, it also took a while to say like, okay, I'm going with a total cost of ownership story to a developer, but he's like, okay, yeah, great story, but my ROI ends at the moment I sell to the end user, which is, Jan Mondaal or the regular guy on the street. So your total cost of ownership thing, partly, sure, it's a quick installation, I have lower interest fees and so on, but you can recycle it, but that's no longer, I have nothing about, because it's no longer my apartment at that point.
Yeah.
So we ran a lot into like...
Unless you introduce product as a service.
Yes. Agreed. We tried. You need a whole lot of money.
Yeah. Yeah.
And we went to the banks. I had like an intern, made some calls to like the big leasing organizations, and they're like, is it a fixed or is it a non-fixed asset? I'm like, it's in a building, so it's a fixed asset. No, because you can remove it. Oh yeah, but then it doesn't fit in a model. No. So end of story.
Yeah. It's
I mean, and we will get there. I'm very positive. But I noticed in practice, like it's you run into some silly things at times.
Yeah, it's true.
But anyway, we do see that there's becoming more and more attention, and it's going in the right direction. And but I was surprised that the price thing is so important, and total cost of ownership, sure, if they keep it, which is happening more and more now in Belgium, because developers are now building more buildings for rental.
Mm-hmm.
So then you have a completely different story. But if it was traditional model of we build, we sell.
Yeah.
Anyway, I'm keeping an eye on the time. Yes. So let's see. Or like any specific questions, because audience, we sent some questions in preparation. So or like any specific points that you still wanted to bring up before we bring it to a close with some more of our more traditional personal questions at the end of a podcast?
Yeah.
For me, also one. You can start.
I was thinking one of the interesting things is like, okay, where do we see the industry in a couple of years? Or what are, let's say, the developments?
Absolutely.
So when when I speak from my personal experience, I think there are two important things. What we are clearly seeing for construction materials is a clear shift in standardization from initial performance to durability. And with durability, I mean long-term performance, right? So, great example, again, a concrete mix. Now, we are typically seeing at compressive strength, but the compressive strength doesn't necessarily say something about the life expectancy of a concrete, because that's related to your resistance against chloride intrusion and so on. And you're clearly seeing that shift towards like, okay, but we have to think about long-term performance, which actually, it changes the scope entirely. So that's an important one. And then, as I said, and you said it already, you're clearly seeing that people are stepping away from the lowest price only. And green public procurement is a great example of that. We are working with a lot of people from the industry, for example, the ports, but we're also looking into working together with the public road authorities to introduce, let's say, the framework from the PhD, so that they can also start implementing it on, let's say, the future projects.
Yeah, that would be amazing. That would be really, really good if they start using that. Absolutely.
And the shift from short-term performance to long-term performance is also, it's important because it takes the eye from initial quality to long-term quality of a product. And that will also lead to maybe products that are now very cheap, but they only last for a couple of years, to like, okay, but it's long-term, it doesn't perform anymore, so it gets out of the market.
Mm-hmm. Mm-hmm. Another one that I recently, a while ago, that I ran into, which I think could also be really interesting to explore to help the more innovative or clean technologies reach scale quicker, is I think it was in the US, there are certain markets from public procurement where they say, look, government, you need to do business with scale-ups, startups for X% of all the public procurement that you do. And of course, it cannot be a big percentage because, of course, you will have problems working with younger, smaller businesses as a government. But something that we run into in the past is public procurement. It's even if they would go to more clean requirements, certain amount of paperwork, certain legislative hurdles you need to jump that are just not feasible for a scale-up, let alone for a startup. So I do think that if something like that could be added, that could also make quite
indeed
an improvement.
That actually directly complements where I would have liked to go.
Okay.
Because one of your questions was also, what are the barriers of today's society to increase sustainability, to increase circularity in construction? And it's actually standardization. There are a lot of standards available, but almost none of them are actually related to sustainability, related to circularity. And what you just mentioned, also procedures. There are no standard procedures. If a standard procedure could be implemented for governments already to really move towards green public procurement and also prioritize startups that really want to introduce an improved product for sustainability, that would already help. And then, of course, standard procedures, standard certificates for reusable components, for more easy recyclability of materials. All these are things that are just non-existent, and we really need them to proceed. Yeah,
absolutely. Yeah, that's something that we also were quite surprised with when we started to operate in the market. I think in in different markets, I can't really come up with examples here, but we have very strict like badges to say this is a circular product, or this is a circular solution, or this is. And in construction, you have these things on a building level, the BREEAM and but on a product level, as far as I'm aware, it hasn't.
On a product level, you have the EPD, and for example, there is an additional impact category which says something about the material that is recycled or can be recycled. So that links to the circularity. It's not necessarily the same, but on a product level, you have the EPDs, which can be used. But you always have to go a step further to the building level. And I mean, for buildings, we have, for example, Totem, which is an LCA software. And that uses the EPDs that are currently available in Belgium to calculate the environmental impact of a
But
building.
that's also on a building level, Totem?
Totem is also on a building level,
Yeah, lots of them are on a building level today.
Yeah.
There's just one more that is already there for circularity. It's the cradle-to-cradle certificate.
Yeah.
But it doesn't really cover the full scope.
Yeah. Okay. That was already very interesting, I must say. So now we have this tradition to finish off with a couple more random or personal questions. So, interestingly enough, they told me before we started recording that I should skip the book question. Which was a surprise, although maybe not, because you already read a lot as an academic, I can imagine. But maybe then we do the first one. So if you could have a drink with anyone, dead or alive, Always a fun one, Kostas. If you want to go first.
I've got a good one.
Okay.
Yeah.
Shoot.
My passion is history, apart from circularity.
Okay.
And a person that would be very interesting today to have a drink with is Emperor Constantine.
Okay.
Not just because he has my name, but also because he lived in a time where the Roman Empire was actually crumbling, and he needed something really fast to recover it, to get it on top again. And he introduced Christianity as a state religion, right? But somehow he managed to completely overturn society and again move forwards. And that's actually what we need today. We need a new religion. A new religion is sustainability, circularity. How can we implement it just like that overnight? And that's something that I think he could help us with.
Wow, that's a great answer. That's one of the better ones, I must say. So that's how it went. He was emperor and the Roman Empire was failing. And then he thought, all right, let's go Christianity. We make it a law.
The legend says that he had a dream.
Okay.
And in this dream, the cross of Jesus Christ appeared with a saying in Latin, in hoc signo vincit. In this sign, you will prevail.
Whoa.
And then he, supposedly, according to the legend, he realized, okay, Christianity is the way to go.
And then he made it the national religion across the empire, and then they flourished again.
He wrote the Bible, basically.
Oh, really?
Yes.
Oh, whoa. Wow. Fascinating. And then the empire really took off again for a while.
Yes.
Oh, wow.
At least for another 150 years, and then of course the West Roman Empire fell. But yeah,
150 years. That's not nothing. All right, great answer.
Yeah. Yeah, mine is definitely not going to be as wow as Kostas.
But
yeah, I think I'm gonna go for the obvious one,
okay,
which is the engineer of engineers, and it's Leonardo da Vinci.
Right.
I mean, just if you look at that time, he was like a visionary working on innovation. So, I mean, it kind of come close to what a researcher is doing. And you said previously, like, okay, if we talk to people like hundreds of years in the future and we look back at how it's done today, what would they think? But I think it's also an interesting one to have the discussion with the people from the past, saying like, okay, this is what it turned out. Is it what you expected? Or so I think, yeah, it can be a great discussion.
Yeah, absolutely. I think I didn't finish it, but I once read part of the biography from Walter Isaacson.
Yeah, I've read it.
Yeah,
it's one of the books that I have read. But
yeah. It was beautiful. I had a big copy with like beautiful images. It was great. Yeah, fascinating guy. Yeah? The how wide he went in his experimentation and his knowledge.
Indeed.
Yeah. That's definitely one we can recommend as a book. At least one book got on the list. Yeah. And then maybe to close off, any event or person, not a book, but that has recently inspired you or has influenced your work or your life? If anyone comes up with anything.
I've got a good one. Very recent.
Okay.
So, 10 days ago, I went to Bao. And I thought, let's have a look. Huh?
Okay.
What does the construction sector say today? There was not a single word about sustainability. There was not a single word about circularity. And then they proposed new techniques like spraying per installation in timber frames. And I was completely appalled, actually. So yes, it inspired me to do better, because we really need to do better than that. Especially nothing. Especially at the largest construction fair in Belgium, we need to do better than that. Yeah, oof. It was an inspiration somehow.
Yeah. Oh, yeah. That's frustrating. I can imagine, but indeed, it can give you a lot of energy to help to improve.
Continue. Yeah. Yes.
All right.
Yeah, I think not let's say one specific event or company, but yeah, because of B.Cycle, of course, we had a lot of discussions with company over the past months, or at least I had a lot of discussions over the past months. And I mean, for me, it's really nice to see that a lot of companies are putting effort into sustainability. And I mean, it's quite nice to see that as an industry, construction industry, even though not everybody is doing it, but there are people who are really pushing it. And I do believe that we will come up with future solutions and make the entire industry more sustainable.
That's those are great words, I think, to come to a close. Kostas, Ben, I would like to thank you very much.
Thank you for having us.
Thank you for having us. Yes.
It was a very interesting conversation. And I really hope that things you researched are going to get implemented on the biggest possible scale. So if whatever small part we could have helped with doing that, with this conversation, that would be great. So everything that was discussed will be in the show notes for the audience. And then if you have any questions about anything that was discussed, you can reach Ben and Kostas directly, also via the information below. So thank you very much for listening. And maybe we talk again in a couple of years if there is new research, right?
Yeah.
Sounds like a plan.
Right. Thank you very much, guys. Bye-bye. Thanks for listening to the Bao Podcast. If you enjoyed this conversation, make sure to subscribe to our channel. If you're interested in Bao Living in our Smart Adaptable Module or SAM, go check out our website baoliving.com. If you want to stay up to date, you can best subscribe to our monthly newsletter on our website or follow us on all social media platforms where we're named @Bao Living.